Hello everyone. Today I'll do another quick Spike demo, and in this demo, for a backstory, until this point, Spike was using like a admin root login key or a root passphrase to initialize itself and also log into the system and get temporary tokens. But while discussing with the team, we realized that since we are using SPIFFE, we don't need passwords. The best point and the best part of SPIFFE is its ability to negate the effect of doing or requiring password-based authentication. So in this demo, I'm going to show how you can access to a secret store, get secrets, set secrets, and receive secrets securely without needing a API key or a root token or a root password or anything like that using Spike. I'll show that. And for the ones that are new to Spike, the Spike website is spike.ist. Let me paste it here. This is the website. This is the GitHub repo. Let me show you on a browser as well. I think spike.ist is the website that we have, like all of the system design documents, roadmap. Since everything is really in progress and highly iterating, some of the things might not catch up with what we have in the repository or what we have in the discussions in our Slack workspace. But other than that, like there's this green button, which is the GitHub repository. If you go to the GitHub, and while you're at there, if you like give us a star, you'll be highly appreciated, because the more stars we have, the more people will know about this amazing technology, and it will be really useful for the community as well. It's the least someone can give as a gift, I guess. So that's that one. This is the Spike's repository, github.com SPIFFE Spike, and spike.ist is the website. And let me switch to the demo, and I'll also explain what I am doing. So we have a bunch of scripts under the hack folder. It's like I'll first start the Spire server and followed by a Spire agent. So I'll have like these two running, and it will be like our identity control plane in a sense. After that, I'm going to create. Actually, I'm going to start two Spike components. One of them is Spike Nexus, and the other component is Spike Keeper. Spike Nexus and Spike Keeper communicate with each other using MTLS that will be provided with the SPIFFE that we have created here. So this communication will be, let me get my text widget here again. This communication will be mutual TLS. And Spike Nexus is our secret store. It will keep the secrets, and as a user we'll use the Spike binary to reach to the store, set secrets, get secrets, and things like that. So that's that one. It will be easier when I show things rather than talk about them. So let's start the Spire server first. Hack Spire server starter. It will first build the recent Spike binaries, and then I'll have a Spire server up and running. I want to split this terminal into two, and down below I'll also run hack Spire agent starter. It will start a Spire agent. So I'll have a Spire server and a Spire agent. Just give me a second. Okay, my Spire agent has also started. So next up, I'm going to start the core components of Spike. One of them is Nexus and the other is Keeper. I'll start with Keeper and then I'll start Nexus. So let me split this panel into two as well. Let's do a split down. Let's start Keeper. The Keeper will start. And if you are curious about what these components are, you can go to the architecture and like read more about the Spike system overview, what Nexus does, what Keeper does, and what is the overall design. But for the sake of this demo, we need Nexus as the secret store and the Keeper as the crypto material backup, redundant backup place for Spike Nexus. So let me start Nexus as well. Nexus will be our store where we are going to store our secrets. So we have Nexus, we have Keeper, and these two folks will like periodically exchange some trust material again using MTLS. So this interaction will be also secure. And along with those, I have a Spike binary. So what I can do is I can just use Spike and maybe I'll get a help document or something like that. So if I call Spike, right now the connection will wait, it will hang up. And if I go to this the Spire server and Spire agent view, we can see that like it's the Spire agent is giving warnings saying that I cannot issue any identity, and the reason for that is I'm trying to run the binary, but there is no SPIFFE IDs assigned to this binary. There is no certificate, and that's why I am not able to log into the system. So what I'll do is I'll cancel this one. I'll list the hack folder again. I have a bunch of helper scripts here that helps me to like enable myself authenticated essentially. One of them is this register Leonardo script. So there I have a user called Leonardo on this machine. So this shell script creates a SPIFFE ID or actually a Spire server registration entry for Leonardo. So when Leonardo logs in, that person will have a entry and they can use Spike. So before running this, I want to like log in as Leonardo first. I log in as Leonardo. It will ask for my password. I'll enter it. And now I'm Leonardo at Spike. But still, as Leonardo, I cannot still use the binary because I still don't have the permission to do it. So as Leonardo's admin, I need to assign the identity to Leonardo so that Leonardo can log in and use the binary. And that is this register Leonardo shell script. So let me cat that one first. Hack register Leonardo. So it is. Let me quickly talk about what's happening. So for Leonardo, we are creating a SPIFFE identifier, and that will be tied to an X509 digital certificate. And this way, Leonardo can use that certificate to identify itself. This is a Spire server registration entry. And for Leonardo to be able to get this identity, that user needs to have Leonardo's user ID. That user needs to be running the binary that is assigned here, and the binary should have the hash that we have computed, which means even if the Leonardo tries to use a different binary, they cannot, because the hash will not match. So the user cannot use a forged binary. They have to use the actual Spike binary to interact with the secret store. And to be able to use the binary, they have to be that user. So I have to shell in as Leonardo to be able to use Spike. I cannot use Spike as admin user right now. So if I do a Spike, it will hang up. But if I log in as Leonardo, and if you remember last time, I wasn't able to use it, but now I think I cannot still use it because I haven't run the script. So let's try it. It won't work. Let me exit. And now I'll register Leonardo, it will create a registration entry for the user. So next time Leonardo logs in to the system from their terminal, from wherever, it doesn't matter because this registration entry is on this machine, then they can be able to interact with Spike and set secrets, remove secrets, and things like that. Let me try that one. So if I run Spike now, I can see a help message, which means the connection didn't hang up. I was able to get an ID. If I go back to the logs, I can now see that, come on, this Leonardo user has been assigned an SVID. So things are working really fine in that area. And I can do anything with this store because we have given Leonardo a super user privileges. Later down the line, we'll have more fine-grained policies around how which principal can access what kind of secret how. But for now, we can just create secrets. For example, I can do a Spike list. It will say there are no secrets. I can do a Spike put, I don't know, organization Acme DB, and then user Spike, password Spike Rux, and then I can do a Spike get org Acme DB, and I'll get the secret. So far so good, but what if I want to temporarily allow Leonardo to use this, and then I want to revoke the privileges? Let's hack, and I have a unregistered Leonardo to say womp womp bye bye to Leonardo. So let's do a clear. Let's cat that one first. Cat hack unregistered Leonardo. It does the Spire server entry deletion. With the Spire server entry delete, we remove the registration entry that deems the Leonardo user as super admin from Spire server. So when Leonardo tries next time, my assumption is they won't be able to use Spike. So let's run this one. Hack unregistered Leonardo, but not define SPIFFE ID. What? Let me. Okay, Spire server entry list, entry show. Let's see, where is Leonardo's entry? Keeper, Nexus. This is the super user. This is our Leonardo. So entry. Okay, I need to do it by entry ID or by, I don't know, by whatever ID, but at least I have this entry ID. So if I copy this one, clear, and let me update this script. This is the, I thought I would be able to do it with SPIFFE ID, but for whatever reason I have to provide an entry ID. But still, we can query the entry and provide it. That's available to us as the admin user of this Spire server as well. So let me quit and then try to unregister Leonardo again. Hack unregister Leonardo, and yeah, it deleted the entry. So if I log in as Leonardo, okay, I'll try to log in as Leonardo again. It will ask for my password. I'm in, clear. Then I'll try to run Spike, ping, and now again I'm hanging up because I don't have any registration entry. And when I look at the Spire agent logs, I can see that again I am getting errors because I'm trying to fetch a certificate, and Spire agent says, hey, I cannot give you your certificate because I cannot attest you. I don't have any registration entry that is related to you, so I cannot let you use this binary. which is really good because in a nutshell, it enables us to not use any kind of application specific secret. So we are authenticating the user by the attributes that the user has. So in a Linux environment, since I am a Linux user, I already authenticated to the system. I don't have to authenticate myself yet another time to a application, essentially, because my credentials identify myself. First of all, we reduce the attack surface of the secret store because we don't have to deal with keeping usernames and passwords and service tokens and things like that secure. We trust the boundary of the Linux box that we are in. So as long as we are a legitimate user and as long as a admin has given access to our legitimate user to use the binary, that user will be able to use the binary. And if there is no need to use the binary anymore, then we can revoke the access, and the system will be secure because unless there is a registration entry, nobody will be able to access the secret store. Nobody will be able to create secrets or modify secrets or define policies on the secrets. But overall, that's all there is that I can show you about how you can get and set and read secrets from a secret store, which is Spike, without having to use usernames or passwords or secrets or tokens. Hope you liked it. Until the next demo, keep your secrets secret.